Okay, this is lesson 9-7, solving systems of equations algebraically. In parentheses out beside that, I would write the word substitution because that's kind of easier for me to it's easier for me to remember, so I think it'll be easier for you to think about substituting in. That's how we're going to solve. So solving systems of equations algebraically. Okay, so what we're using is substitution. So it says solve this system of equations algebraically. So they give us y equals x plus 2 and y equals 5. So they actually go ahead and tell us what y is. We know y is 5. So I'm going to take that. I like to draw lines. It gets helpful when they get more complicated. And plug it in for y on the other equation, or substitute it in. So that first equation is now going to read 5 equals x plus 2. Once we have that, we can solve for x. I get it by itself with the equal sign by subtracting 2 from both sides. 5 minus 2 is 3, so x equals 3. So your answer here is actually the point xy. So 3, 5. That is your solution. Okay, if you were to graph it like what we did yesterday, that is where the two graphs would intersect, is the point 3, 5. Okay, I'm going to go ahead and let you try that to get good practice, and it doesn't have to be y that's solved for first. It could have been x and then solve for y. You're just solving for both. The order isn't necessarily important. So go ahead and try all three of these to get good practice. You're solving them by substitution or using it algebraically. So do all three of those, and then I will go over it with you. Okay, on these first few examples, we are solving these by algebraically, which means we're using substitution. So always look for the one that's easier, the one that's already solved. So like on this first one, we have y equals 5 and y equals x plus 4. They are both already solved for y, but this one is simpler. It's just y equals 5. So take this one and plug it into the other equation for y. So my new equation for this one is going to be 5 equals x plus 4. Now we solve for x. I subtract 4 to the other side. 5 minus 4 is 1. So I've solved for x, it's 1. Since I've already plugged into this equation, I'm now going to take that and plug it back into the first one. But if you notice, there is no x. It's already solved for y. So on this one, it already did half of it for us. Our point is 1, 5. Okay, on 1b, I have y equals 7 minus x and x equals 3. They already did half of it. X equals 3. So we take that and plug it in for x on the other equation. So I have y equals 7 minus 3. 7 minus 3 is 4. So my solution is the point 3, 4. Okay, last one. Again, they've already done x. We take it and plug it in for x on the other equation. And then now solve for y. -3 minus 4 more is -7. So the point, or the answer here, is -3, -7. Okay, next example, we're doing the same thing. But if you notice, neither one of these are given to us for x or y. So we're going to have to solve for both variables. So what you do is just look at these and see if any of them are easier than the other to solve for. Even if you solve for the more complicated one, it's still going to work out. So that means looking at this equation, I could solve for x or I could solve for y. Or looking at this equation, I could solve for x or for y. If you notice on this one, this x and y both have a coefficient, a number out front, and so does this x. This y does not. So to make it easier on myself, I'm going to solve for y on this equation because that means less steps or less work. Even if I solve for the other ones, it'll still get you the same answer. So I'm going to solve for y on this top one, which means to get it by itself with the equal sign, I have to get rid of this 3x, the whole thing. So to move it to the other side, I'm going to do the opposite and add 3x to both sides of that equal sign. When we do that, we get that y equals -13 plus 3x. Okay, I haven't done anything yet. All I did was solve one of them for y. Now this is where the word substitution really comes in, because I'm going to take that, what it says y equals, hold on, let that go away. I'm going to take what it says y equals, so -13 plus 3x, and I'm going to plug it in for y on the other equation. Okay, this is why I draw arrows, because here in a second it'll help. So I'm going to rewrite this equation, 4x plus 5y, but instead of y, in parentheses, because that means 5 times y, I'm now going to have all of this. So we have 4x plus 5 times negative 13 plus 3x equals 11. So to solve now, because I don't have a y, I just have x's, so we solve for x. I've got to distribute this 5 first. So 4x plus 5 times negative 13 is negative 65. 5 times 3x is 15x, so plus 15x equals 11. From here, these two x's are on the same side of the equal sign. So do what's between them. That's positive 4x plus 15x, which gives me 19x. Minus 65 equals 11. So to solve for x, I get rid of this 65, so I add it to the other side of the equal sign. And it cancels, and I'm left with 19x equals 76. Now to get x by itself and just get rid of the 19, you divide both sides by 19, and you get that x equals 4. Okay, well, we're not done. We're only half done. I have half of my solution. I know what x is now. So to figure out what y is, I take that value for x. This is why I drew an arrow. I've already plugged in, switch colors. I have already plugged into this equation. So that means now the answer that I got, I have to plug it in to the one I haven't plugged into yet. If I notice, I already drew an arrow to that one, so I know I've plugged into it already. So I'm going to take that x equals 4, and plug it in for x on the first equation. Okay, so let me scroll down some. So now I have y minus 3x, but instead of x, I'm now going to replace it with 4. So y minus 3 times 4 equals negative 13. Negative 3 times 4 is negative 12. To get y by itself here, we add 12 to both sides of the equal sign. And I get y equals negative 13 plus 12 is negative 1. So my x is 4, my y is negative 1. That is our solution. So these take a while because you're having to work out what seems like two different problems, but you are substituting one into the other to solve, and then substituting back to solve for the other variable to get your solution. So we're going to go ahead and try both of these. I know this takes a while. Please take your time so you can get good at this. Remember, this chapter is important. This is the last lesson in this chapter. So solve algebraically, so using your substitution on 2a and 2b. So you're going to have to solve for one of the variables first. Okay, try that, and then I will go over it with you. 2a and 2b, we're doing the same thing. We just have to look at it, and we're going to have to solve for something first. So again, look for the easiest thing. So I have 2x, negative 3y. On bottom, I have 4x and y. The reason the easiest one to solve for is going to be y on this second one is because it doesn't have a coefficient, a number out front that we would have to divide. We could just get it by itself with the equal sign, the easiest. We could solve for any of them. That's just the simplest one to start with. So to get this y by itself with the equal sign, I have to get rid of the 4 and the x. So I subtract it to the other side of the equal sign. I can't combine these because one has an x and one doesn't. So I'll leave it 1 minus 4x equals y. I now have it solved for y. So I'm going to take this, since it tells me that that's what y equals, and I'm going to plug it in for y on the other equation. I have it 3 times that. So whenever I rewrite that equation, I have 2x minus 3 instead of times y. It's now going to be times all of this. That's why it's helpful to put it in parentheses. Because now if we look, I've got to distribute that negative 3 in there. Negative 3 times 1 is negative 3. Negative 3 times negative 4x is positive 12x. I have to solve for x. I have 2 of them, and they are on the same side of the equal sign, so we can combine them. 2x plus 12x is 14x. I add 3 to the other side. Did I copy this right? I don't remember that coming out so bad. Oh, no, because that one's negative. Never mind, it's going to work out. Negative 10 plus 3 is negative 7. Then we have to divide by 14, and we get negative 1/2, or negative 0.5. So what we do, since I have already plugged into this equation, I now take what I got for x and plug it in for x on the other equation. That's why I like to draw arrows to know which one I've already plugged into. So now on this one, instead of 1 minus 4x, I have 1 minus 4 times negative 1/2 equals y. Okay, half of 4 is 2. Negative times a negative is a positive. So y is 3. So my solution here is negative 1/2, 3. That one was kind of tricky with the half. Okay, on 2b, same thing on this one. There are 4 different correct ways to solve. So, being that none of these are easier than the other one, it's anybody's game. I could solve for this equation first, and I could solve for x, or I could solve for y. Or I could choose to solve for this equation first, and I could also solve for x, or I could solve for y. So there's 4 different ways to start this one. So, just because you did it different than me doesn't mean you're wrong. I'm going to solve for x on this first equation. So, I'm going to add 4y to the other side. Can't combine that. And then I have to divide everything by 2. So x equals 3 plus 2y. So I'm going to take that, since that was my first equation, and I'm going to plug that in for x on this second equation. So instead of 3x, I have 3 times all of this that we said x equals. And now I can solve for y. I distribute my 3. And I have 2 y's on the same side of the equal sign, so I just do what's between them. That's positive 6y minus 5y. So that is just y. Subtract 9 to the other side. 3 minus 9 is negative 6. So I have my y. We still have to get x. I have already plugged into this second equation, so I'm going to take that and plug it back into the other equation, the first one, for y. I'm going to write it up at the top. So 2x minus 4 times negative 6 equals 6. Negative 4 times negative 6 is positive 24. Subtract, wrong thing. Subtract 24. Let's see. 6 minus, so that's negative 18. Divide by 2. X is negative 9. So our solution here is the point negative 9, negative 6. Okay, so now this says if you're solving your system of equations, which is what we're doing, and you get a false statement, then that means the answer is no solution. If it comes out to a true statement, it has infinitely many solutions. So we're going to talk about what that means. So on example 3, it tells us to solve this system of equations algebraically, which is what we've been doing. I have y equals x plus 5 and 2y minus 2x equals 10. So this one is already solved for y. So I'm going to take that, since it tells me that's what y equals, I'm going to plug it in for y on the other equation. So instead of 2 times y, I'm going to have 2 times all of this now. So 2 times x plus 5 minus 2x equals 10. I finished rewriting that equation. So I have to distribute. 2 times x is just 2x, plus 2 times 5 is 10. Since these x's are on the same side of the equal sign, we do what's between them. That's a positive 2x minus 2x. That cancels because that equals 0. And I'm left with 10 equals 10. So what this statement is talking about is when your variables cancel out. So you might want to make a note of that. If your x or y cancels out and it's true, okay, so we know 10 equals 10. That is true. That means your answer is infinitely many. So if your variable cancels and it's a true statement, it's infinitely many. If your variable cancels and say that had come out to 5 equals 10, that would be false. If it's a false statement, the answer is no solution. Okay, so I want you to try both of these. Again, I know it takes a little long to work these out, but try both of these, and then I will go over it with you. Got a couple more problems doing the same thing. On 3a, I have 4x plus 2y equals 8, and y equals negative 2x plus 4. Since this one already is solved for y, I'm going to take that and plug it in for y on the other equation. So 4x plus 2 times y. Y is now all of this, so we put it in parentheses. equals 8. So the first thing I have to do is distribute. 2 times negative 2x is negative 4x. 2 times 4 is 8. So my x's are on the same side of the equal sign, so do what's between them. 4x minus 4x, they cancel, and I am left with 8 equals 8. Since that is true, and my x cancels no matter what, the answer to this one is infinitely many. That just means if we were to graph them, they are the same line. So you would just have a graph that looked like one line, even though it was two. Okay, on 3b. None of these are solved yet. I'm going to solve this one for x. It doesn't matter which one. So let's see, add y to the other side. 1 plus y. Now I'm solved for x, so I'm going to take this, plug it in for x on the first equation. 1 plus y minus y equals negative 4. Y minus y cancels, and I'm left with 1 equals negative 4. And that will never be true. That means there is no solution. What that means is if we were to graph that one, these lines would be parallel. They're never going to cross or intersect at any point.